Human civilization was built by those willing to step into the unknown. Every major breakthrough, from electricity to artificial intelligence, began with someone pushing past fear to investigate a forbidden question. But history demonstrates that the curiosity capable of curing a disease can just as easily engineer a pandemic. The boundary between a technological leap and an uncontainable catastrophe is razor thin. Inside the secret laboratories of the Manhattan Project, elite physicists operated under relentless pressure to turn theoretical equations into a physical weapon. In that high-stakes environment, they discovered that knowledge itself can become lethal. Among their most dangerous tools was a 6-kilogram plutonium sphere nicknamed the Demon Core. Researchers used it to conduct criticality experiments, a process they called tickling the dragon's tail, where they intentionally pushed the material to the absolute edge of a runaway nuclear reaction. The danger turned fatal when familiarity led to a lack of caution. During one experiment, physicist Louis Slotin used an ordinary flathead screwdriver to keep two beryllium hemispheres apart. The tool slipped. The shell closed. A blinding burst of blue light filled the room, the signature of ionized air from intense, lethal radiation. These were not reckless amateurs. They were the brightest minds of their generation. Yet repeated exposure to extreme power normalized the risks until their desire for answers finally overpowered their instinctive caution. At the absolute frontier of science, a microscopic physical error can instantly transform an act of genius into a fatal, uncontainable disaster. As the scale of nuclear research expanded, the potential blast radius grew, from a single laboratory to the entire planet. Before the first atomic test, theoretical physicist Edward Teller presented a terrifying hypothesis that the weapon might ignite a global firestorm. Scientists feared the heat from the detonation would be so intense it might cause the nitrogen nuclei in the air to undergo a runaway fusion reaction, effectively setting the Earth's atmosphere on fire. The psychological tension at Los Alamos became so high that some researchers argued the project should stop if even a microscopic chance of global annihilation existed. Others used humor as a coping mechanism, with Enrico Fermi reportedly taking wagers on whether the bomb would merely destroy New Mexico or incinerate the world. The military proceeded with the detonation regardless. It was the first time a single human experiment carried existential consequences for the entire species. In hindsight, the calculations were correct. The atmosphere did not ignite, but the precedent of risking the planet had been set. Decades later, a new generation of physicists confronted a similar fear at the Large Hadron Collider. This massive machine was designed to smash particles at energies never before produced on Earth, attempting to simulate conditions just after the Big Bang. Public anxiety surged over theoretical risks that were once again planetary in scale. Lawsuits attempted to halt the collider, fueled by claims that it could create microscopic black holes or trigger vacuum decay, a hypothetical event that would collapse the structure of reality itself. While safety reviews suggested these events were impossible, the controversy highlighted a recurring truth. Humanity is constantly advancing into energy regimes where theoretical certainty can never be absolute. The deeper ethical dilemma is whether any level of uncertainty is acceptable once the stakes include the total destruction of our world. This dilemma now extends into biology, which introduces a danger physics does not: evolution. Unlike a nuclear reaction, viruses and bacteria mutate, adapt, and reproduce independently after they escape containment. This makes gain-of-function research uniquely unpredictable. By intentionally modifying pathogens to become more lethal or transmissible, scientists hope to prepare for future pandemics. But in doing so, they create the very risks they are trying to avoid. The concern is not theoretical. Laboratory accidents involving dangerous pathogens happen far more frequently than the public realizes, often caused by simple human error or equipment failure. During the Cold War, the Soviet biopreparator program exploited this knowledge to secretly develop weaponized antibiotic-resistant strains of plague and anthrax. These programs operated under the terrifying reality that biological containment systems are never foolproof. Biology reveals a disturbing truth. Once the knowledge to engineer life exists, containment becomes a matter of political will rather than technical capability. Once the boundary is crossed, the danger can replicate on its own. We have now entered an era where artificial intelligence and synthetic biology are merging, removing the final barriers to the manipulation of life. Autonomous laboratories can now generate hypotheses and synthesize new chemical compounds at speeds no human team can match. These systems often create molecular structures whose mechanisms are not fully understood even by their creators. This technology is dangerously asymmetrical. Algorithms designed for healing pharmaceuticals can be repurposed within hours to discover highly toxic nerve agents by reversing optimization goals. Historically, the pace of dangerous discovery was limited by human bottlenecks, ethical hesitation, exhaustion, and institutional review. Automation erodes those safeguards. Systems can now iterate continuously, designing and testing compounds without direct human oversight. By the time we understand the implications of a new discovery, it may already physically exist. Our capacity to engineer destructive technologies is now growing faster than our ability to govern them. We are handing immense power to systems that do not share our instinctive caution. The ultimate test of the 21st century is no longer whether we have the intelligence to deconstruct the fundamental laws of nature. It is whether a species psychologically similar to those who once balanced plutonium with screwdrivers can survive the power we've unleashed.